Hello, this video is for IXL Activity 8.F.19. This lesson is titled Relationship Between Squares and Square Roots, and the 3-character code for this activity is 8 Whiskey 2. So you can see here our first two questions. They're asking us to simplify these expressions. Notice that they are radical expressions, or that is to say square root problems. You notice that by this radical symbol here in each problem. And you can also see that we have something being raised to the power of 2 in both of these problems. And whenever we raise something to the power of 2, then that means that we are squaring that particular value. So in the first example here, I have a radicand. A radicand is the number that is underneath the radical symbol. I have a radicand that is being squared, 16 squared. And we would have to square that and then take the square root of it. So this is taking the square root of a square, right? Or how do I want to say that? It's the square root of a square. That would be what we're doing here. So let's go ahead and first deal with that 16 squared underneath, right? So we have 16 squared, and let's go ahead and simplify this. Now if I do 16 times 16, 16 times 16 over the side here, 6 times 6 is 36. We're going to carry that 3, that's going to give us a 9. That's 16, and we have 6, 5, carry the 1, 256. So we'd end up with 256. Now we need to know what is the square root of 256. That means what number times itself equals 256. Well, that's not too hard. We just got done doing it, right? 16 times 16 is 256. So the square root of 256 is going to be 16. So let's go ahead and put 16 as our answer. Now, you might be thinking, wait a second, the answer is the radicand, right? What's being squared? The answer turned out to be equal to whatever it was that was being squared underneath the radical symbol. So let's see how that works out with our next problem. Looking for a pattern, right? So on the next one, it says that we have to do what's in parentheses first and then square it. So we have the square root of 25, and we have it squared. This means that we need to take the square root of 25 first. Well, the square root of 25 is 5, right? Now, what was in parentheses, we're going to square. So that would be 5 squared. And 5 squared equals 25. So our answer here is 25. So it looks like that if I take the square root of a square, then I end up with whatever this value is right here that was being squared underneath the square root symbol. Or if I square a square root, it looks like I end up with the radicand. And if you're wondering, is that always true? Indeed, it is. So let's go ahead and look at our two different examples again. Here we have the square root of a square. So inside, underneath the square root symbol, we have something being squared, 4 squared. So we have square root 4 squared. Now we take the square root, if we square 4, 4 times 4 is 16. Then if we take the square root of 16, indeed, we get 4 back. So you'll see that whenever you take the square root of a square, you get the value that was being squared underneath the radical symbol. What about the square of a square root? So we're going to take a square root. Here we have square root 81, and it's in parentheses, so we need to go ahead and simplify it first. Square root of 81 is 9. It's still in parentheses. Now apply that. Now we need to square our square root that we got. 9 times 9 is 81. And lo and behold, we end up with the exact answer of the value that was underneath the square root symbol. So indeed, that's the way that the relationship between square roots and squares is, that if you take the square root of a square, you end up with the value, the same exact value that's being squared underneath the square root symbol. And if you square a square root, then you end up with the value of the radicand that's underneath the square root symbol that you're going to be squaring later on. Kind of a tongue twister there. A lot of the word square seems to be floating around quite a bit. Now, you might wonder, how does understanding the relationship between squares and square roots help? Well, here I have an example of a quadratic equation here. It's quadratic because we have a value, a variable that's being raised to the second power, Anytime you have some variable being raised to second power, it's going to be a quadratic function. So we need to solve for x in this case. Well, first of all, the x squared is tied to the 13 through addition, so we need to subtract 13 from each side. What we do to one side, we're going to do to the other. So that's kind of our basic algebra process there for solving things. 38 minus 13 is going to be 25. Now, we get down to the point where we're saying some value of x squared equals 25. Now, we could probably do this in our head. We could realize, oh, okay, x times x equals some number. Okay, what's x going to equal? Oh, that would equal 5. 5 times 5 equals 25. So you'd be like, okay, x equals 5. Well, sometimes it's not always a nice, simple, perfect square. It might end up being a decimal. And you're wondering how do you deal with this x to the square, right? Because your textbook or your IXL activity is asking a question like x equals some number, right? You're supposed to put your answer in there, x equals some value. Well, right now you have x squared, but you just want to get to x. Well, if we take the square root of a square, what happens? We just end up with that value of x. So if we take the square root of what's on the left and the square root of what's on the right, because what we do to one side, we have to do to the other, we now realize that the square root of a square is just going to give us whatever that value is that's being squared underneath the square root symbol. Wow. But basically it gets rid of the square root symbol. Taking the square root of something that's squared gets rid of the square for us, and we just get that value that was being squared. Now, go ahead and simplify square root of 25, and we end up with 5. So you put, oh, okay, x equals 5 in this case. And indeed, if you plug that back in, 5 times 5 is 25, plus 13, indeed, equals 38. Always check your answer. Make sure that you always plug your answer back in. Make sure you have the correct answer. So let's do just a few more questions. Don't really have to work these out, really. The square root of 176 squared. So this is the square root of a square. So we're just going to get 176. Over here we have a square root being squared. Well, we're just going to get the value that's the radicand. The value of the radicand is 850.5. What about the square root of 635.7 squared? So this is a square root that's being squared. So we know that we're just going to take the value of the radicand. 635.7 would be our answer. And then finally, last example here is, what is the square root of 98.6 squared? Well, we're just going to take this value here that's being squared underneath the square root symbol, and it's going to be 98.6. So for this activity, if you're wondering, Mr. T, is it really that easy? We just go through whatever this number is that's underneath the radical symbol, whether it's a square, taking the square root of a square, or whether it's squaring a square root. We're just going to take the radicand, the value that's underneath the radical symbol, and just that's the answer. And indeed, it is indeed that simple. The point of it is for you to understand the relationship between square roots and squares, so that problems like this here later on down the road, whenever you're trying to deal with something x squared and trying to get it down to just x, you realize you need to take the square root of both sides, and then you'll find your solution here. All right, so that's everything I have for IXL activity 8.F.19, relationship between squares and square roots. Good luck with your activity.